All right, we're taking a deep dive today into some cutting-edge AI research.
Sounds exciting.
It is actually. We're looking at this paper, DroidSpeak, Enhancing Cross-LLM Communication. Have you had a chance to look at this one yet?
Yeah, I took a look. It's tackling a really significant bottleneck that's been holding back those multi-agent AI systems, where you've got multiple LLMs working together.
Like a team of specialized AI agents.
Exactly right. Think of it like a software development team, but all AI, where each agent has a specific role, like coding, design, project management.
And they have to constantly communicate with each other to get anything done.
Yeah, which is where the problem comes in.
Because right now, they're spending way too much time just talking to each other.
It's a huge drain on efficiency. Current multi-agent systems rely heavily on natural language for communication. So every time one of these AI agents receives a message, it has to go through this really computationally expensive process, what the research calls a prefill phase.
To basically understand the context of what's being said.
Right. It has to sort of reread everything that's come before just to process that one new piece of information.
So if you think about it in human terms,
It's like having to read an entire email thread every time someone replies.
it's just to get to that one new sentence at the bottom.
Exactly. Talk about inefficient.
And it gets even worse when you're dealing with complex tasks that generate huge amounts of data.
Oh, absolutely. The research gives some real-world examples like MapCoder, where you have AI agents competing in programming challenges, and Reflection, where they're learning from feedback.
Those can involve massive amounts of text being generated back and forth.
Yeah, which means even more time wasted on prefill.
And that's where DroidSpeak comes in, right?
That's where it comes in. And it's got a pretty clever solution.
Instead of relying on natural language.
It uses these intermediate data representations, things like embedding caches, eCache for short and key value caches, or KV cache.
Data that the sending LLMs has already computed.
Yeah, so instead of sending the whole book, so to speak,
DroidSpeak is sending the cliff notes.
precisely, the receiving LLM can use that pre-processed information to skip a lot of the heavy lifting, that computationally expensive prefill phase.
Interesting. And the paper mentions that DroidSpeak works particularly well with LLMs that are fine-tuned versions of the same base model.
Right. That's because even though they might have different specializations, like one's focused on coding and one's focused on design.
Under the hood, they still share a lot of the same underlying structure.
Exactly. They're surprisingly similar, and DroidSpeak takes advantage of that.
But wouldn't sending all of that cache data be overwhelming? I mean, wouldn't that create its own bottleneck?
It could, yeah. But that's where the real ingenuity of DroidSpeak comes in. It uses what they call layer-wise optimization.
So it's not just blindly sending everything.
Right. It analyzes which layers of the sending and receiving models are similar enough to reuse.
It's identifying those parts where they're already speaking the same language, so to speak.
Exactly. And only recomputing the parts that are absolutely necessary.
And that's where the significant speed gains come from.
Right. The research shows up to a 2.78x speedup in prefill latency, which is pretty impressive, and all that with only a negligible loss in accuracy.
Wow, that is impressive. But I'm guessing there are trade-offs to consider.
Of course, there always are. One of the main ones is memory usage.
Because sending all those caches back and forth takes up more memory, especially on the GPU.
Right. And depending on the size of the caches, it can also increase the transmission time, which could offset some of those speed gains.
So it's all about finding the right balance for each application.
Absolutely. The DroidSpeak research actually looks at a few different strategies for doing just that. They test different combinations of reusing the eCache, the KV cache, or both.
It's like a menu of optimization options.
Yeah, you could say that.
It sounds like they're really taking a nuanced approach to optimizing communication between these AI agents.
They are, and the results speak for themselves.
Can you give us an example, like a specific task where they saw a significant improvement?
Sure. One that stood out to me was their work with the Hotpot QA dataset, which is a benchmark for question answering systems.
Okay.
They used a pair of LLMs, Llama 370B as the sender, and Llama 370B Instruct as the receiver.
So two different versions of the same base model.
Right. And the receiver, the Instruct version, is typically more accurate, but also more computationally expensive because it needs to process more information.
So the goal was to speed up that processing without sacrificing accuracy.
Exactly. And they were able to achieve a 1.72x speedup compared to the receiver processing everything from scratch.
Pretty significant.
Yeah. And the F1 score, which is a common metric for question answering, only dropped slightly, from 61.2 to 60.2.
So a very small drop in accuracy for a pretty big gain in speed.
Right.
It's worth noting, though, that the speedup they got with DroidSpeak varied depending on the specific model pair and the task.
Yeah, the amount of layer reuse they saw was different in each case, which shows that there's not a one-size-fits-all approach.
It's all about finding the right configuration for the specific situation.
Absolutely. Which is honestly one of the things that makes this research so interesting.
There's a lot of potential for further exploration and optimization, especially as these multi-agent AI systems get more complex and the tasks we're asking them to perform get more demanding.
Oh, absolutely. This research is just scratching the surface of what's possible.
But even at this early stage,
it's highlighting some really fascinating insights about how LLMs communicate and how we can make that communication much more efficient.
Now, we've talked a lot about the technical side of DroidSpeak, the speed gains and the trade-offs, but I'm curious about the broader implications of this research.
Okay, I like that.
Like, what does it tell us about LLMs and their potential for collaboration? What are your thoughts on that?
That's a great question. I think one of the most profound implications of DroidSpeak is the insight it provides into the similarities between seemingly different LLMs,
Even those that have been fine-tuned for different tasks?
Right. We tend to think of these specialized models as being quite distinct from one another, each with their own unique knowledge and capabilities, but DroidSpeak suggests that there might be a lot more common ground than we initially realize.
Interesting.
The fact that they can share so much intermediate data so effectively suggests a deeper level of shared understanding than we might expect.
It's almost like they're speaking different dialects of the same language, and DroidSpeak is helping them translate more efficiently.
I like that analogy. It's very fitting.
And it raises some really intriguing questions.
Like, if these models are more alike than we thought,
Could they actually understand each other's reasoning, not just their outputs?
right, and could that lead to a more collaborative form of AI where agents can genuinely work together to solve complex problems? I mean, that's a really powerful vision.
It is. And it suggests that DroidSpeak could not only optimize AI performance,
But also advance our understanding of how these systems learn, communicate, and collaborate.
it's like we're peering into the inner workings of their artificial minds and finding new ways to connect them.
Exactly, and that's what makes this research so exciting.
It's not just about making AI faster, it's about opening up new avenues for exploring the full potential of artificial intelligence.
I agree. It's really pushing the boundaries.
Well, this has been a fascinating discussion so far.
It has. I'm really enjoying this.
We've covered a lot of ground, from the technical details of DroidSpeak to its broader implications for the future of AI.
Lots to unpack with this one.
There is.
Yeah.
But there's still much more to explore.
Like those nuances of layer-wise optimization, the challenges of memory management, and the potential for adapting DroidSpeak to different types of LLMs.
All really important considerations.
Yeah, definitely worth digging into.
Let's do that. We'll continue our deep dive into DroidSpeak in the next part of this episode.
Sounds good. Welcome back. It's great to be continuing our deep dive into DroidSpeak.
Yeah, where we left off, we were talking about how DroidSpeak could potentially do more than just speed up communication between AI agents.
Right.
We might even give us some insights into how these large language models actually think.
Yeah, and I think one of the key insights here is that more data isn't always the answer. The research actually found that just blindly reusing all of the sender LLM's key value cache, that KV cache, can actually sometimes make the receiver LLM less accurate.
That's pretty counterintuitive. You'd think more information would lead to better results, right?
Yeah, you would. But it turns out that even when you have these fine-tuned LLMs that come from the same base model, they can still have pretty significant differences in those later layers, where the specialized knowledge is.
So transferring all that KV cache from the early layers could actually introduce inconsistencies.
Yeah, or even contradictions, which would obviously hurt the performance.
Makes sense. And that's where the layer-wise optimization of DroidSpeak really comes into play.
Exactly. By being really selective about which layers of the KV cache to reuse, you can maintain accuracy while still getting those impressive speedups.
It's not just about sending more data. It's about sending the right data.
Right. And the research looks at different trade-offs between reusing different types of cache data. You've got the eCache, the KV cache, or a combination of both. It's all about finding that sweet spot, the optimal balance for the particular application, the models being used, and how much accuracy you need.
So there's no one-size-fits-all solution.
Not really, no. Each situation is unique.
Now, you mentioned earlier that DroidSpeak has been mainly tested with fine-tuned LLMs that share the same base model. What about LLMs that are more different, like with different architectures or training data? Could DroidSpeak help bridge that communication gap, do you think?
That's a really interesting question. While the research doesn't specifically address that, I think the underlying principles of DroidSpeak could potentially be adapted and expanded to work with more diverse LLMs.
So it might not be a universal solution just yet, but it could pave the way for more efficient communication across a wider range of AI models.
I think so, yeah. Imagine a future where AI agents with all sorts of different backgrounds and training data can seamlessly collaborate, sharing their unique perspectives. That's a pretty powerful vision, right?
It is. It really speaks to the potential for unlocking a whole new level of collaborative intelligence.
Exactly. Now, let's go back to the challenge of memory overhead for a minute. We talked about how sending these caches back and forth takes up a lot of memory, especially on the GPU. Could this be a limiting factor for real-world applications? Like, what if you're running these AI systems on devices with limited resources?
It's definitely a valid concern, and the research does acknowledge that limitation. They suggest exploring things like advanced compression techniques, to shrink the size of the caches before they're transmitted.
So compressing the cliff notes even further?
Yeah, exactly. And they also mention these adaptive caching mechanisms that could dynamically adjust how much data is being reused, depending on things like latency constraints and available resources.
So instead of always sending the full cache, the system could make smarter decisions on the fly about what's really necessary.
Right, optimizing for both speed and memory efficiency at the same time.
Yeah, it's a really clever approach, and I think there's a lot of room for innovation in this area, especially as we move towards more complex and demanding multi-agent AI systems.
Absolutely. Now, before we wrap up this part, I want to go back to something you said earlier about DroidSpeak shedding light on the fundamental nature of how LLMs communicate.
Right.
Can you elaborate on that a bit more?
Sure. I think one of the most profound takeaways from this research is that even when LLMs are fine-tuned for different tasks, they might still share a lot more common ground than we initially thought.
Right, their underlying thought processes, so to speak, could be more similar than we realize, even though they're specialized for different things.
Exactly. And by figuring out which layers of the models are similar enough to reuse, DroidSpeak is giving us these valuable clues about how these models learn and process information. It's like we're mapping out this shared understanding that exists between them.
It's almost like peering into their internal representations of the world.
And seeing how those representations overlap, which is pretty mind-blowing when you think about it.
It is. It could have some really big implications for our understanding of how AI works, how it thinks.
Absolutely. And it could help us develop new techniques for training and fine-tuning these LLMs, for designing better communication protocols.
It's a reminder that we're still early on in exploring the possibilities of LLMs, and there's a lot more to discover.
I agree. It's a really exciting time to be working in this field.
All right, so we've gone pretty deep on DroidSpeak, looked at how it works, its potential to really change the game for AI collaboration, and even what it might reveal about, how these large language models actually think. As we wrap up this deep dive, what are your final thoughts? What should our listeners really be thinking about after listening to all this?
I think the most striking thing about DroidSpeak is that it's not trying to reinvent the wheel. It's really cleverly leveraging these existing efficiencies that are already built into LLMs.
Right, instead of forcing the AIs to explain everything in detail every single time.
Exactly. DroidSpeak lets them communicate in this kind of shorthand, a way that they already understand. And that leads to some pretty impressive speed improvements.
Yeah, we saw speedups of up to 2.78x.
Which is huge. And all that with barely any loss in accuracy.
Which opens up so many possibilities.
Like, imagine real-time collaboration between these AI agents, much more complex and responsive AI systems, even, maybe even a future where AI can keep up with how fast humans think.
That's exciting to think about.
It really is. But it's not just about speed, right? The other big takeaway here, and maybe the most profound one, is what DroidSpeak tells us about how LLMs communicate at a fundamental level.
That's right, because by analyzing which layers of these models can be reused, we're getting a much deeper understanding of how they represent information, how they process it.
We're basically creating this map of the common ground between these artificial minds, and we're finding this shared understanding that goes way beyond their specific training, which is pretty fascinating.
Yeah, it makes you wonder if those shared layers represent some kind of fundamental understanding of the world, something that goes beyond the individual tasks these LLMs were designed for.
It's a really intriguing question, and it points to these broader implications of the research. DroidSpeak isn't just about optimizing performance, it's about exploring the very nature of how AIs think, how they communicate.
And who knows what other secrets we might uncover as we continue down this path.
Absolutely. This is really just the beginning.
Well, this has been an incredibly insightful conversation. You've given our listeners a lot to think about.
My pleasure. I always enjoy talking about this stuff.
DroidSpeak really has the potential to revolutionize AI collaboration, maybe even offer a glimpse into the minds of machines. It raises some really big questions about the future of AI communication.
It does. I encourage everyone listening to check out the full research paper, dig into the details, and really consider the possibilities. AI is moving so fast, it's such an exciting time to be following all this.
Could agree more. Thank you so much for joining us for this deep dive. Your insights have been really valuable.
Thanks for having me. It's been a great conversation. To everyone listening, keep exploring, keep asking questions, and keep pushing the boundaries of what's possible with AI.
That's great advice. And that concludes our deep dive into DroidSpeak. We'll see you next time for another deep dive into the world of AI research.